Okay, so my apologies again. In this video, I will not have the use of the stylus pen, so I will be largely just talking, which again, it could be bad, but I will do my best to make it not seem so bad. Okay, well, let's start here. Uh, Here we go. Okay, so this chapter, chapter 7, is all about costs and the production choice that's being made by the firm. So, what we need to think about is that the production choice is going to be a choice that is cost minimizing. So, if it's trying to minimize its costs, we would also need to have an understanding of what costs are. So, that's where we start on this slide here. And one of the more important things we need to do is we need to separate economic costs from accounting costs, with the difference being that a accounting cost basically is anything that can be measured. Um, and the things that could be measured are essentially um, uh, both negative. The negative being the fact that equipment wears out as it's used over time or becomes outdated. So that would be the depreciation. And then it also counts addition. So that'd be basically anything that can be monetized where you would actually have to write a check or issue an invoice or something um, to pay for the item. The economic cost is different. The economic cost involves something a bit more um, difficult to measure, and that more difficult thing to measure would be the opportunity cost. So it's what you could have done otherwise with that item. It is something that you need to take into account. Can't neglect it just because sometimes it can't be measured or it's less than certain. It is still important. Um, and the reason why those opportunity costs are important, we know them even as individual consumers. They're important because it means that that if you could be doing something else instead with that money, with that equipment, then maybe you should consider that as an option if that alternative has a higher value. The thing, though, that should not be considered, and this is the most difficult part, the thing that should not be considered are sunk costs. Very important. Sunk costs should have no influence on a decision. And yet, probably not at least once a week, I hear of someone making a decision who is considering sunk costs. Um, what was the one today? I guess the one I heard about today, which was regarding our campus, and it was like, wow, we've got this very big, expensive campus. It's expensive to maintain. We can't go online. We can't put more classes online because we have to justify why we built such an expensive campus. That decision was made decades ago. We can't go back and get rid of that. We should really only be thinking about the path forward, and what students want today, what faculty members want today, what employers want today. That should be more important than, well, I guess we got a campus, so we got to use it to teach, so we got to fill it up. That's a sunk cost, and sunk cost should not have any influence. Okay, again, I will skip examples here. So, what are the costs? What are some of these accounting costs? Well, the first Um, the summation of all the costs come into what's called the total cost. Total costs are equal to fixed costs plus variable costs. So total cost is equal to fixed cost plus variable costs. Fixed costs are basically a single number. It's basically something that will not change as the quantity changes. It's just there. And so whether you're producing 0 units or a bajillion units, that cost is always the same. The only way you get rid of the fixed cost is if you shut down and you stop operations entirely. The variable cost changes with the output. Um, and there, if you're producing nothing, then variable cost is zero. So typically, um, well, let's. So COVID happens, right? And for a lot of companies, what they would typically do, right, is if they shut down, they would get rid of all their workers, right? They'd lay them off or fire them, get rid of them basically, and then they would just pay off their equipment over time. And one of the reactions of the government for COVID was that they were going to provide money to employers to keep workers employed. The reasoning behind that was that workers are basically a variable cost. If the production drops to zero, then the variable cost will drop to zero because they got rid of the employees. They didn't want the employees to be gotten rid of. So what they did essentially was transition them to becoming a fixed cost, because the only way you get the government to pay for things for you and whatnot was if you kept the employee hired for 9 months or whatever, some certain period of time. And that essentially transitioned the employee into becoming a fixed cost. Um, if every month that I live in my house, I have to pay a mortgage, whether I live in the house or not, the mortgage is due. But if I don't live in the house, I could turn off all my electric, all of my utilities, cancel the internet, and my variable cost would be zero. But my fixed cost would remain that mortgage. So, um, when we think of what it means for a firm to shut down, basically it means that they um, if they um, if they stop active operations, that's how they'll reduce their variable costs down to zero. The only way that they could get all of their costs down to zero, including the fixed costs, the only way to do that would be to basically go out of business. The only way to do that would be that they, sell the operations. So just because you say that a firm shuts down, it doesn't necessarily mean it went out of business. It could either mean that the variable costs were brought down to zero, or that the company itself was sold and disposed of. The best way to determine whether something is a fixed cost or a variable cost is basically, does it have a Q, an output, in the equation? Because as we write out the equation, typically it has a form where total cost equals some constant number, let's say 300,000, plus 2200 Q, which would basically mean as Q goes up, as the output goes up, costs go up by $2,200. Well, that would be a variable cost. Every Q we make, costs go up by 2200. In the example I kind of made up here. Um, Again, the difference of a fixed cost versus a sunk cost. The sunk costs are again something that you're never going to get back. A fixed cost could presumably, um, you could get some of that money back if you sold your business. You could get some of that fixed costs back, those fixed costs back, um, and the fixed costs stop once you go out of business entirely. The sunk cost, it was a past decision. You just need to move past it in order to make your decision of what to do in the future. Okay. Don't worry about this slide. I can't cross it out, but don't worry about amortization. Um, let's not worry about that for this class. Okay, and I'm going to skip this example. So, this is a pretty important chart to understand. It should make uh, the mathematical relationship between the lines here should make hopefully quite a bit of sense. So we've got the output on the far left-hand side, and you would see that in column 2, fixed costs, it's not changing. So in this case, it's always 50. No matter how much or how little is produced, it's always 50. At quantity 0 of output, right here, you can see that the variable cost is 0. Column 1 plus column 2 equals column 3. Total costs. So in this case, variable cost is 0 at quantity 0. Now, in columns 4 through 7 at quantity 0, it's basically undefined. We don't have to worry about anything because there is either we're dividing by 0 or there is no change. So let's now go to the second row. The third row for output being 1 unit. When the output is 1 unit, the fixed cost still remains $50. The variable costs, meaning the materials, the workers, whatever, the things that change as you produce more or less units, that's also 50. So column 1 plus column 2, 50 plus 50 equals 100. That's column 3. Now, how much is the change in column 2 or column 3? Doesn't matter which one, but either one. What's the change in column 2 or 3 as we went from quantity 0 to quantity 1? That would be a change of 50. So column 4 here is basically measuring the change in either column 2 or column 3. It doesn't matter which one, because any change in total cost would all have to be generated from the change in variable costs. So it doesn't really matter which one you use here for marginal cost. So that's a change of 50. You can see here when I go from 50 to 78, that's why this is 28, which is the same as going from 100 to 128. Column 5 is simply column 1 divided by the quantity. So 50 divided by 1, 50 divided by 2, that's why this is 25. 50 divided by 3, 50 divided by 4, and so on. Column 6 is column 2 divided by the quantity. So this would be 50 divided by 1, 78 divided by 2. So 78 divided by 2 is 39. And so on and so forth. And then finally, column 7, average total cost, that would be column 3 divided by the quantity. And that's what you see right here. Okay. So that's what we see. Sorry, let me blow my nose, but I'm going to pause it. Okay, so the marginal cost is measuring our change in either our variable cost or our total cost. It can be either, but it's the change in the costs as the quantity changes. Again, fixed costs don't change at all. So in that previous example, it was always 50. But the marginal cost is measuring that If I want to produce one more unit, so in this case here, if I want to go from unit 1 to unit 2, then we would see that my variable cost went from 50 to 78. That's an increase of 28. And that's what this is right here. So column 4 is basically measuring the delta of either 2 or 3. Okay. And then the average is just by definition. It's just dividing it by quantity. Why does that look like that? Okay, well, this is kind of describing what the graphs look like on the next page. So I'm just going to skip over this for right now and just talk about why they're shaped the way they are. Okay. So what you see here is that, let's start with the top graph first, right here. Let's see here. Let's get out of that. Let's zoom in here. And, oh yeah. Sorry, I'm not trying to move that. Sorry, I'm not going to try to do what I was doing. Let's just go back to this. Okay, so if you look at the top graph right here, what you'll see is that our fixed cost is constant, so it's a horizontal line. Nothing strange there. Then you would see that the total cost curve is getting closer and closer, right? Sorry, not getting closer and closer, but increasing at a decreasing rate and then increasing at an increasing rate. So it's always increasing. It's just in the beginning, the slope is getting flatter and flatter and flatter, and then steeper and steeper and steeper. The variable cost curve has the exact same shape, and the vertical distance between the two curves is constant. The vertical distance between the two is the fixed cost. Now, the slope of the total cost curve and the variable cost curve is the marginal cost. So that would mean that the marginal cost is getting lower and lower and lower, and then higher and higher and higher. And that's exactly what happens here. Lower and lower and lower, and then higher and higher and higher. The average fixed costs would go flatter and flatter to the origin because the numerator is constant, but the denominator is getting larger and larger and larger. So the total ratio would be getting smaller and smaller. The vertical distance between ATC and AVC is AFC. So average fixed cost plus average variable cost equals average total cost. But what you would notice here is that average fixed costs are getting smaller and smaller and smaller. So that would mean that the vertical distance between the two is getting smaller and smaller and smaller. Okay. I've probably said enough about all that. What this slide here is describing is basically a rule within mathematics. Let me just go back here. That basically whenever the marginal is below the average, it's driving down the marginal curves. Sorry, it's driving down the average curves. When the marginal is below the average, it's driving down the average curves. And then when the marginal is above the average, then it's driving up the average curves. And that's just mathematically the case. And that's what you see right here. Now, let's see here. What is it? This is describing this in a really this slide is a very confusing slide if you just tried to read this slide. Let me tell you what's essentially going on here. One of the questions you would ask yourself perhaps is, why is the total cost curve or variable cost curve shaped that way? Well, it turns out that it's actually a mirror image, meaning it's opposite of the production curve. Why is that the case? Why is it? And so in this case, if this is getting flatter and flatter in the beginning, why would you produce more and more in the beginning and then less and less? Right? Because here it's going steeper and steeper. So why is the production curve going up and up, steeper and steeper, and then flatter and flatter? The reason why is because of what we saw in the previous chapter of the marginal productivity of labor. What happens in the very beginning as I try to produce stuff and I hire one more worker? When I hire one more worker, I get a lot of output out of them, which means that there's very little labor in each of those workers, which is why my total costs aren't rising that much, right? Because my costs aren't going up that much. There's very little workers in those very beginning units because they're very, very productive. Well, what happens when the firm gets too large? Well, then workers are like stealing. Workers are like, fake workers, and they're just collecting a paycheck for doing nothing. Which would mean that at that extreme, you've got too many workers, too many labor units within each unit of production, which would mean you've got a lot of costs, but not a lot of production. And that is essentially what this graph is talking about here, is that basically the cost curve is a mirror image of the production curve. Again, if I'm not talking about it, you don't really need to know it that much, because if I'm not talking about it, so you're not going to get tested on it if I'm not talking about it. Skip this slide. And so now what we need to do is transition from thinking about costs in the short run to thinking about costs in the long run. So the thing, what is it that makes it in the long run? It becomes the long run because there are no longer any fixed costs. So everything is variable, which now means that the firm has a much different way that they need to think about things. Because now all of their workers are variable, all of their capital is variable. And so as a consequence, they need to now make an appropriate choice of how much to use, how much capital to use, and how many workers to use. So this would be where we introduce this idea of firm choice. So what's the rent? What's the price of? Before we get into this, actually, so here we're going to talk about the cost minimizing input choice. The easiest way I can define this for you is that it's the exact same way we thought of the utility maximizing consumer choice. So So this isn't on the slide. I'm just kind of talking here. But do you remember how we thought about how a consumer makes an optimal decision? That they basically they're presented with what their budget is, basically what they can afford. And then they're trying to basically get the highest indifference curve that they can afford. And so the firm is a little bit different. All that the firm is trying to do is it's trying to maximize how much it can produce. So that's what it's trying to maximize. But it's not going to be trying to cut its cost to as cheap as possible. It's trying to minimize its costs. So what are the costs? The costs would be um, they have to pay to we call it the rental rate of capital. Even if you own the item, we still call it the rental rate because essentially when you own something, you're basically renting it to yourself. So the price of capital is the rental rate. Why didn't they give you? Jeez, why is they are odd? Okay. Well, they decided not to tell you what the other input would be, which would be workers. Workers, the price there is the wage rate. So there's our two inputs: rental rate of capital, wages of workers. Trying to minimize how many inputs they have. And essentially what we do is we take their wage rate times the number of workers and add on to it the rental rate of capital times the amount of capital. That's our ISO cost line. All the combinations that basically cost the same. So these blue lines here represent ISO cost lines. And we have a stated unit of output here, Q1. This is called the Isoquant. So basically, we want to choose the amount of labor and capital that minimizes the costs subject to the Isoquant that we're trying to get, which would be Isocost 2, or sorry, 1. The alternative way to do this would be to say, I've only got this certain amount of budget. I only have this certain budget. So what's the maximum production I can get from that budget amount? That'd be an alternative way of understanding the optimal consumer choice. Now, we can alter what the ISO cost line looks like when we change the price of an input. That could potentially then lead to a change in the inputs that you use. So, for instance, if workers become more expensive, the firm is probably going to substitute some of those workers for machines to produce the items. So here you can kind of see the same kind of setup as we had for um, the consumer choice. Remember, for the consumer choice, we took the marginal utility of each item and divided it by the price of each item and set those equal to each other. Now, all we're going to do is take the marginal productivity of each input and divide it by the price of that input. Cross multiply, and we'll be able to solve for labor and capital, which is what you have to do in the problem set. Okay, you can skip this. And then what that leads us to do is we would probably try to look for an expansion path. And so what the expansion path would trace out is it would trace out all the points of tangency between the ISO cost lines and the ISO cost lines. It's called an expansion path because it basically then traces out how a firm could internally decide to expand its operations. What that expansion path leads to is it leads to a tracing out of the long run cost curve. And that's what we see right here. So in the upper graph, we do see our expansion path, which is basically tracing out all different levels of output for different levels of a different budget level or a different ISO cost line. And we can essentially then redraw the graph and we can get a long run total cost curve by showing what cost level, what ISO cost amount we have versus the amount of production. So these two graphs are related to one another, just having different things represented on the axes. Okay, and I'm going to skip again our example here. What we tend to see, and what is generally true, is that a firm basically faces more restrictions in the short run than in the long run. And so, because they face these greater restrictions, what tends to happen is that the expansion path tends to be nearly horizontal, whereas an expansion path in the long run is typically at a 45-degree angle or something pretty darn close to it, and that's because all of the inputs are variable. Okay. Trying to think, I don't want to go through all of these slides when not all the slides are very important. And I'm skipping through because I've now largely talked about the most important things that I wanted to talk about. I know this is a longer. There's one thing I want. There's at least one more thing I want to talk about here, and that would be the economies of scale versus the diseconomies of scale. So what the firm does when it has to, when it's thinking about expanding its operations, it has to think about how its costs are changing. So basically what you're looking at here is the difference between, cost changing versus output changing. If it's the case that you double your output, but you less than double your costs, that's what we would call an economy of scale. Basically, you would become better at producing things as you become larger, largely for the reason as it identifies here in number 1, that your workers become more specialized and you just produce more stuff. Eventually, though, all firms at some point do become too complex, and that would be where we have diseconomies of scale. And what diseconomies of scale represent would be that my costs are increasing by a greater factor than what my outputs are increasing by. And why is that? Again, the firm just becomes more inefficient as it produces more and more. Okay. Oh yeah, look at that, the Gigafactory for Tesla. That's a pretty good example of economies of scale. The last thing. Yeah, is this the last thing? Yeah. So we don't need to do that. Okay, so the very last thing I want to talk about here is this graph right here. This is the last thing. So basically, the long run average cost curve, its shape is it's an envelope of the short run cost curves. And so if we look at these points where the um, short run marginal cost reaches intersects the lowest point of the short run average cost curve, if we traced out all of those various short run average cost and short run marginal cost curves and where they intersect at the minimum, that shapes the lower bound of the long run average cost curve. And so the long run curve is basically determined by the shape of the short run curves. It creates the shape of that curve. It is U shaped, but the shape itself comes from those minimum points on these short run curves. Okay. I know there's a lot more slides here than we need. The one thing I would say is this is a summer class. So we're not obviously covering everything. We're even doing some of these things in the appendix, but in the problem set. But we're obviously not doing that to that extent. Because we have to cover so much, some of these chapters are a little bit. I'm covering them a little bit faster, a little bit more accelerated, I guess would be the right way to say it. Um, but we are doing you don't have to worry that you're getting less material. You're getting the same amount of material. It's just we're really focusing on what the most important things are that you would see in the problem set and what you would see on the exam. Okay, that finishes a rather short discussion for chapter 7.